I will introduce it. I'm sorry I'm on here twice, but I'm using two laptops, one that I can write on and one that I can follow you guys on. And it's spinning at the moment. I need it to be recording before I can get started, so sorry about that. And we're waiting and waiting and waiting. Hey, I know what you guys could do. All right, it's starting to record. So good morning, everybody who's joining us for the recorded version of the retake review session for the stoichiometry test. I'm going to encourage everybody right now to have a pencil, a paper, and a calculator. Oh, and your gold periodic table. But the other thing I'm going to encourage you to do, and if you're listening to the recorded version, you could just pause me. But you might, if you're listening to me live, you might want to go to Moodle. I have a review worksheet that I'm going to be going over. And I posted the answers down at the bottom of that review worksheet. You might want to pull that worksheet up just so that you can look at the numbers. If you can go faster than me and you don't need to sit and listen to this whole review session, more power to you. Otherwise, you can sit and listen. So it's at the top of our Moodle page right now. So up at the top, it says our Google Meet and how to get into the Google Meet. And then right underneath it, it says, I think, Retake Review Worksheet. You could click on that and open it and just try your hand at those. I'm going to go through all of the problems. So if you're struggling a little bit, I'll go through everything. But if you feel like you can work ahead of me, be my guest. By the way, the retake is tomorrow at 1 p.m. I really, really, really need people to be there at 1 p.m. and to not tell me they have conflicts. However, I do understand that 1 p.m. is your fourth block class. So if you have something you have to do for your fourth block class, then we'll figure something else out. You need to communicate with me why you can't be there at 1 o'clock, and then I'll figure something else out for you. It gets to be a lot for me to manage all these different times and all these different versions of the test. So hopefully everybody can be there at 1 o'clock. And if you can't, let me know. Okay, I'm going to go ahead. I've got two laptops working at the same time. I'm going to go ahead and present from my second laptop, if I can remember how to do it. And I will work through these problems, and it should look just exactly like the test. Give me just a second here. That's not right. There we go. Present now. My entire screen. So the worksheet that I am going over with you guys should look exactly like the test. The test has a few more questions, but they're just repeat questions. It's the same type of question. I just ask it twice. So this should be a really good review for you. Okay, so you should be seeing what I'm seeing on my computer right now, and I'm going to go ahead and open up Squid, and I'm going to fold over my Chromebook so one of my cameras will be facing the ceiling. I maybe should have just turned that camera off, I guess, now that I think about it. Okay, so actually, you don't even see that camera. No, you do see it as up on the ceiling. Okay. Anyway, here's our retake review worksheet. So what I told you the test would always include, there are 2 moles to moles problems, and number 1 is your moles to moles problem, and it's just a repeat. For the second one would be another one. I told you there will be 2 grams to moles or moles to grams questions. So that's what question number 2 is a grams to moles question. I told you there would be 1 grams to grams question, and that one is worth 3 points because it's 3 steps to get there. And then at the end, there's a question about a limiting reactant, the number of moles that are going to be produced based on the limiting reactant, how much excess there is of the excess reactant, and then our percent yield. So I set this worksheet up to look just like your test. This would be a great thing to do with me and then to have sitting next to you when you go to do the retake. This is open note. You're allowed to look at notes. It's not open friend. We did have some issues with that on this test, so I would really appreciate it if you would not use your friends as resources. Use me, you guys. Cheat with me. I'm the one who helps all the time. If you're frozen, you're panicking, I'm the one to cheat with. Contact me and let me know, and we'll work it through together. So just, It's so time consuming when I have to deal with people doing dishonest work. If you just come to me, I will help you get through it and you don't have to do the dishonest work. And then it saves me and I'm happy. Okay, moving on. Let's go ahead and take a look. I chose a really big equation for us, something that you won't necessarily see the exact same on our test. So we've got, it says question number 1, if you start with 4.36 moles of HCl, how many moles of Cl2 will be produced? Well, the first thing that I'm going to notice, and I'm going to change colors here just to make it stand out a little bit, I notice that the HCl is a 16 coefficient, and I notice that the Cl is a 5. So we're going to have a 16:5 or a 5:16 ratio, and that's called the mole-to-mole ratio. So I'm going to go ahead and skip over here, and I'm going to write, this is problem number 1. So we have 4.36 moles of, and I forgot already what it was, HCl. That was easy. HCl, and I write down, so always when we're starting these problems, I think the mole-to-mole problems are pretty easy, and most of you did really well on them, but I always write down what they give me on the left, and then I make a long space on my paper, and I write down what I want on the right, what they're asking me on the right. So they're asking for, what are the moles of Cl2? That's what they're looking for. Now, all I'm doing is going from moles to moles, and if you don't know this, you should write it down. Moles to moles is just one conversion factor. It's one step, and it's only worth 1 point on the test. So I'm going to go ahead and write my conversion factor. If you are organized, the number one, there were 2 issues actually that I saw on the test. Some people are not very good at adding up their atomic masses. So when you had to do grams to moles or grams to grams, you didn't add it up right. So for those of you, I gave you partial credit. So maybe you saw that you had a 0.5. That might mean that you didn't add your masses correctly. So just be careful with that. So that was one easy mistake. But then the next mistake, I have to say, is sheer laziness, and that's not writing down your labels. If you write down your labels, it will save 90% of your mistakes. The reason is that you can see what has to go on the bottom of the conversion factor based on what you had previously. So right now I see that I have moles of HCl. That's the unit I'm working with. So that means on the bottom I have to have moles of HCl because they're going to cross each other out. They're going to cancel out. That unit will cancel out. I am also looking for moles of Cl2. So then I know moles of Cl2 has to go on the top. I didn't say this already, you guys, but at any time, feel free to turn on your microphone and ask me a question. I don't need to take over all the time. I was just trying to walk you through it. At the end, if you want to stay and ask me more questions, you're certainly welcome to. And Will, I'm going to suggest you turn off your camera just because everybody can see, whatever. It might be a little bit distracting. So, okay. So moving on. So now I see that we have moles over moles. This part right here, I see it's moles over moles. That's the mole-to-mole ratio. So that's where we go back and we take a look at those numbers from the other page, the 16 and the 5. Well, how do we know if it's 16 over 5 or 5 over 16? Well, that's based on what we're trying to get rid of. So we're putting moles of HCl on the bottom. That was the 16. And we're putting moles of Cl2 on the top. So that was the 5. And so now we just entered into the calculator. And you maybe should try doing it along with me so you don't get bored and you're making sure that you're good at using your calculator. I did 4.36 times 5 divided by 16, and I got 1.36. When I'm presenting, it's super easy for me to make mistakes. So if you get something different, interrupt me immediately. And if you made a mistake, that's fine. But if I made a mistake, we need to go back and look at it. Because we're recording this, I don't want to screw it up for other people. All right, so any time that you have a mole-to-mole problem, and there's 2 of them on the test, you just have one conversion factor. Write it down. Mole-to-mole equals 1 conversion factor. You're only doing one of these. Now, problem number 2, we'll go back to problem number 2. Problem number 2 is a grams to moles or a moles to grams problem. And in that case, you need to have two conversion factors. So write that down somewhere. Moles to grams or grams to moles equals two conversion factors. That's how you know you've gone far enough or done what you needed to. And again, the secret is often, the secret to doing these well is often about using your labels, not getting lazy, but actually writing down all the words. If you get lazy on a worksheet that I'm not grading, fine. But on your test where it really, really matters, write everything down and you'll be a lot happier. You're less likely to. Yes, Sonia.
Will we have balanced equations, or like do we have to balance them ourselves?
You do not. I decided I would like you to be able to do everything from beginning to end. I would ideally like to be able to give you a word equation and to have you write the molecular formulas, to have you balance, and to do the problems. But that presents so many places where you can make a mistake that the odds of you getting the right answer are often so limited. And it takes so much time that I decided for the test, I'm giving you the balanced equation. So you don't have to worry about that part at all.
Okay.
Good? Okay. All right, so let's take a look at number 2. Number 2 says, if you produce 75.6 grams of H2O, how many moles of KMNO4 were used? So 75.6 is what they gave me, and what I'm looking for is moles of KMNO2. So I'm going to write down what they gave me. So I'm going to scoot this up if I can. Will it let me? Nope, it's not. I'm trying to move my, there we go. I'm trying to move my worksheet. Okay, so problem number 2 was 75.6, was it grams? Now I'm forgetting. I got to pay better attention. 75.6 grams of water, and we want KMNO, so grams of water. So we put that, what they gave us, we write that down on the left, and then what we're trying to solve for, we put over on the right, and what we want is moles. I shouldn't make it like it looks like a conversion factor. Hold on. Oops, sorry. I meant to hit back. Give me just one more chance. I'm going to make a little bit more space. Equals moles of KMNO4. All right, so we're looking for moles of KMNO4. I see that it's a grams to moles, so I know I'm going to have to do two conversion factors. So I'm going to go ahead and write times, and I'm going to make the line, and I'm going to write times, and I'm going to make the line. I can't recommend enough doing it my way. I think my way makes it so visually clear. I know that some of you like to do it in separate, discrete steps. And I think if you do it all at one time, you're much less likely to make a mistake. I know that sounds crazy, but that's my recommendation. Okay, so I see that I have, hi Alyssa, I see you just joined us. I see that we have 75 grams of H2O. So I want to get rid of that unit. So I'm going to put grams of H2O on the bottom, and that will allow us to cross off that unit. I'm just talking right now. I eventually want to get to moles of KMNO4. So I know over here, I'm going to want moles of KMNO4. Okay, so that's helping me get started. That way I know that I have my units kind of in the right place. So now let's keep going with this. I have grams of water. The first thing, whenever I see grams, it's always going to be with 1 mole. That is a hard and fast rule. The only time, write it down somewhere, the only time that you get to use these ratios, let me erase what I had here. The only time that you get to use these ratios is when it's moles over moles, what we call the mole-to-mole ratio. That's the only time that you get to use the coefficients, the big numbers in the front. But when you have grams and moles, what you're looking at is the atomic mass of 1 mole. And so for the grams, we're going to write down what we add up on our periodic table. So we're going to have 2 hydrogens and 1 water. So hydrogen is 1.008 plus 15.999 I got an 18.015. So that's 2 hydrogens and 1 oxygen. So the atomic mass is 18.015. Now, I see that my grams have canceled out, and now my unit is moles of water. I'm trying to get to moles of KMnO4, so I'm going to use a mole to mole ratio to get to the moles of KMnO4. Now, which do I put on the bottom? Which one goes on the bottom? Well, that's where doing it in this order, I think, really helps you out. You want to have the unit that will allow this moles of H2O to disappear. So I'm going to put moles of H2O on the bottom, and now I can cancel them out. Those units are gone, and I'm left with my final unit that I'm looking for to answer this question. So when I see moles and moles, I go back over to my original problem and I look at the ratio. We have, this is the moles here, and this is the moles here. One reason I designed this particular question was because to some of you, it may look like it's backwards. I am going from a product, which is on the right side of the arrow. It's on the right side of the arrow. I'm going from a product, and I'm asking you to tell me a reactant, which is on the other side. It doesn't matter. You can go any direction. You could even look at 2 products. You could look at 2 products and go grams to moles with them. Or you could look at 2 reactants and go grams to moles with them. It doesn't matter what direction you're going. Write down what I give you. That goes on the left. Write all the way on the other side what you're looking for. That goes on the right. And then put however many conversion factors you need in order to solve that problem. Okay, so backing up for a second, let me erase all the little doodles I just made all over here. And what we want to look for in this one is we're looking for the ratio, the mole to mole ratio of water and KMnO4. So it's 2 and 8. So now I'm going to go back. 8 moles of water goes on the bottom. And then 2 moles of KMnO4 goes on the top. Now I have to multiply everything through, and just make sure that you're good at the multiplication. I hate it when people make math errors, like it's just a bummer for you to lose out. I try to catch that, so I try to give you partial credit. If I see when I look at your work that you set everything up and then you got correctly and then you got the wrong answer, I try to give you all the points back except for a half point. So you lose a half point for doing the math wrong, but you get all the other credit for doing the setting it up correctly. So for this one, just to make sure you don't lose out on that half point, it's 75.6 times 2, and then I divide it by, and I'm going to put parentheses around what I divide it by. So it's going to be 18.015 times 8, close parentheses. For this answer, somebody's got their microphone on and we can hear you. I'm going to suggest that you turn your microphones off just because it'll distract other people, unless you're asking a question. All right, so I got an answer. My answer looks like this, 1.049125.7. What should I write down, KJ? What's the right answer? Well, in this case, these don't count for sig figs, so they're irrelevant. What we're looking for is the amount that we gave you. The amount that we gave you had 3 sig figs, so I want your answer to have 3 sig figs. 1.049 rounds to 1.05. So the correct answer is 1.05. There were probably a dozen people that lost a half point or a quarter of a point because their significant figures were so far off. They set up everything and then they didn't round correctly. So don't get lazy. You don't round until the very last step. Don't round this number. Don't round any other number. You round at the very, very end. Once you've gotten your calculation, then you go and round it off to the correct number of sig figs. I will give you no tricky sig fig problems. So there will be no, like the number 100, how many sig figs does the number 100? Nothing tricky like that. Pretty much every time it's going to have 3 sig figs. So you need to have 3 digits in your answer. If you have 3 digits, you're good. Okay.
So KJ.
Go ahead, Will.
So the significant figures, like our final answers, only based off the first number given.
Yeah, well, okay, so that's not quite the way that I would say it, but that's the general idea. So for example, they gave you 4.36 moles. So that's your only number. That's like the only number I gave you in that problem. So yeah, you would go with 3 sig figs because this had 3 sig figs. This is the only number I gave you. It has 3 sig figs. I was trying to be really nice and always give you 3 sig figs. So you pretty much, if you just go with 3, you're good. Take a look at the problem down at the very bottom. This one has several numbers. It has this number, it has this number, and it has this number. But if you remember anything about sig figs, all 3 of them have 3 sig figs. So if your answer has 3, you're probably going to be right on. Excuse me. But that said, don't do your rounding until the very end. Don't start, rounding numbers really early on because you'll start getting further and further from the correct answer. Once you've got the correct answer all the way at the end, then you can round off. Super good question. Well, thank you. Okay, so I think we're ready for problem number 3, unless anybody else had a question about going from grams to moles or moles to grams. They're exactly the same problem. So if I gave you, let's say I said 32.1 moles of, I'm going to go the opposite direction, KMnO4, MnO4. If I gave you that and I said, how many grams of water would form? You do it exactly the same way. You write down what I gave you. You write down on the other side, you write down what you're trying to find, and then give yourself 2 conversion factors because going from moles to grams or grams to moles is 2. I know what I'm going to put on the bottom to get the unit to go away that I start with, KMnO4. I'm going to put that on the bottom so that they cancel each other out. And I need to end. I know that I need to end. I'm going to get the right color here. I'm going to end with grams of water so that they're the same. So I have the same unit. Anytime that I have grams, anytime that I have grams in my conversion factor, it's always going to be 1 mole of whatever it is, because we're talking about the atomic mass of 1 mole from your periodic table. So that you don't get to use the coefficients, and whenever there's a gram present, you don't get to use the coefficients. So the grams of, we figured it out up here, the grams of H2O was 18.015. And now I see that I have moles on the bottom of water, so I must need to put moles of water on the top here so that they cancel out. And so I'm going to cross them off like that. And I see that I'm left with the unit I'm supposed to be left with, so that's good. And now all I have to do is figure out what numbers go here. It's moles over moles, and when it's moles over moles, we get to use the mole ratio, which I already had that same ratio from the previous problem. 8 is what goes with the water, so 8 would go with the water, and 2 goes with the moles of KMnO4. So I just did the reverse problem. I just went from moles to grams instead of grams to moles. You would do 32.1 times 8 times 18.015 divided by parentheses. In this case, you didn't really need the parentheses, but you could. 2 times 1. And that will give you whatever your answer is for that one. So I want to make sure you see that going from grams to moles or going from moles to grams, it's exactly the same. It's 2 conversion factors. They're just the opposite of each other. Okay, I'm talking fast. I'm going to go ahead and move on to the next one. In case anybody has a question, you can always come back to this or ask me another problem. I'm just going to keep scrolling down. So if you do want to come back to a question, when we're all done, I can always scroll back down and we can take a look at it together. Okay, let's go ahead and do problem number 3. And this problem is the one that has A, B, C, D to it. So it's got the limiting reactant and all that stuff. So let's take a look first at how we solve the first part. I'm going to do a little erasing here quickly. All right, for problem number 4, I see that we have this big ginormous equation. Oh, and by the way, just to save ourselves some time today, down at the bottom, do you see this down at the bottom? I gave you the masses of some of them so that you didn't have to figure that out, for like that wouldn't take you hours to figure out, because this is a pretty big equation. So I gave us a few hints so we could go faster. All right, so it says we have 3.23 moles of K blah, 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 19.4 moles of sulfuric acid, H2SO4, and we have 18.7 moles of water. First of all, which one is the limiting reactant? Remember that the limiting reactant is the one that's going to run out first, and therefore the reaction stops because you ran out of it. So what we need to do is to pick one of them. We're going to solve all three of them, and we're going to pick one product and see. So you've got 4 products in this equation. There's a product here. There's a product here. We're going to pick one of the 4 products, and we're going to look at all 3 of the reactants and see how much they produce of that one product. Now, I'm going to make a recommendation, and if this confuses you, then forget it. In part B, I'm asking how many moles of FeSO4 will be produced based on our limiting reactant. So if for part A, you chose FeSO4, if you chose FeSO4 for part A, that would save you some time when you go to part B. Do you need to do it that way? Not at all. So you could do part A and you could say, okay, how many moles of carbon dioxide does each one produce? And then for part B, you could take a look at FeSO4. That works. But if you choose the one that I ask you in the second part, it'll save you a step. And we're all about saving steps, especially because stoichiometry is a lot of writing. Okay, so let's take it from the beginning. The first thing, oh my gosh, you guys, I skipped number 3, didn't I? I jumped down to number 4. Nobody said anything. We really need to take a look at number 3. Should we do number 4 first because I'm talking about it and then go back to number 3? Are we okay if we do number 4 first? I'm really sorry. I didn't mean to screw that up. Okay, nobody's saying anything, so I'm gonna.
Yeah, let's do number 4 first.
Okay, we'll just do number 4 first. Don't let me forget that we need to go back and do a grams to grams. I'm sorry I screwed that up. There's no grams to grams on this one, so it shouldn't be a problem. Okay, so let's do number 4. So I see that we have 3.23 moles of this big ugly element that has cyanide and potassium and iron. I don't even know what the real name of that one would be. So let's go ahead. It's 3.23. So I'm going to change this to number 4. Dum me. All right, number 4. So we had 3.23 moles of that really big one. What was it? Potassium, FeCN. I can't remember what it was. Potassium 4, CN6. Okay, so potassium 4, CN6. There's 6 of them. Just to remind you really quickly, when you're adding up your atomic masses from your periodic table, in this case, you would have 4 of the potassiums, 4 of the Ks, 1 Fe, 6 carbons, and 6 nitrogens. So make sure you're really clear on that. 6 carbons and 6 nitrogens. Okay, so I gave you the atomic mass, so we don't have to worry about that, and we don't need it yet anyway. So, okay, so now, yes.
Did you mean 6 hydrogens? I heard you say nitrogens.
It is nitrogen. It's CN. Does it look like I wrote CH?
It kind of looks a little bit like an H.
Yeah, whatever. Okay.
Okay, I'm sorry.
I was so sloppy. You're totally right. So let's make it look nicer. I'm sorry. So this is, we'll do it again. I will be less careless. So potassium, it was 4, right? Potassium 4, FeCN6. Good. Thank you so much for asking, because if you guys don't speak up and I make a mistake, then I'm going to screw it all up. Okay, so this is the first of the reactants. So this, I'm making it take longer than it really needs to. So we're going to do just a moles to moles problem, and then we're going to figure out how many moles of, and I'm going to go back and look. In problem B, we wanted FeSO4. So I'm going to choose FeSO4. And what I notice about iron sulfate is that it has no coefficient. So it has a coefficient of 1. And I'm comparing it right now to something that also has a coefficient of 1. So that's going to be a simple 1-to-1 ratio. So 1 mole of FeSO4 over 1 mole of K4FeCN6. Now, how did I know which one to put on the top and the bottom? It didn't really matter because it was a 1-to-1 ratio, but notice that I can cancel off my potassium, iron, cyanide, I don't know the right name, and I'm left with the unit that we're looking for, which was moles of FeSO4. Okay, so in this case, it's just a 1-to-1 ratio. It's super easy math. So we're going to have 3.23 moles of FeSO4. That's how much, if we use that much of the first ingredient, we're going to end up with 3.23 moles of FeSO4. So let's try the next one. So the next one is 19.4 moles of H2SO4. So I'm going to write that down in a new color, 19.4 moles of H2SO4. I'm going to draw my conversion factor, and I'm going to see how many moles of FeSO4 that produces. I want to make sure I wrote that all down right. So 19.4 moles of H2SO4, and I'm looking for SCO4. Okay, so the H2SO4 has a coefficient of 6, and the FeSO4 still just has that coefficient of 1, so that makes this one kind of an easy one to do. So we want moles of H2SO4 on the bottom so they cancel out, and we want moles of FeSO4 on the top so that we have them at the end. It's a mole-to-mole ratio again. So it was 6 moles of H2SO4 and 1 mole of FeSO4. So we would do 19.4. I'm going to go ahead and enter that into my calculator. 19.4 times 1, divided by 6, and we would get 3.23. Whoa! Pretty much exactly the same amount. That's interesting. We get basically the same amount there. So now it'll be interesting to see how much we have of the third reactant to see if we have less or more than those. So the third reactant is the, I have so many scribbles, I should change colors so your eyeballs can see it, is the 18.7 moles of water. So I'm going to do that last one. I'm going to do 18.7 moles of water. I'm going to do a conversion factor. I know moles of water has to go on the bottom. I am looking for moles of FeSO4 again. So I'm going to put moles of FeSO4 on the top so that I end with the correct unit and so that my moles of water go away. All right, I see that I have a mole-to-mole ratio to fill in, and I believe it was the same mole-to-mole ratio. If we look back on the thing, water was has a coefficient of 6, and the FeSO4 still has that coefficient of 1. So I'm going to put a 6 down here and a 1 up there. I'm going to multiply them out. 18.7 times 1 equals, divided by 6 is 3.1. Oh, here we go. My answer says 3.1166666. Ooh, evil. 7. What do I write down? Everybody should have an answer, and it should have 3 sig figs. So your answer should be 3.12 would be the right answer because the 6 causes this 1 to round up to 2. Okay, so 3.12 moles of FeSO4. So it looks like this is the smallest amount compared to the other 2. So that means the 18.7 moles of water is my limiting reactant. So for question A, I would say that the limiting reactant was the 18.7 moles of water. Now, B is totally related, and because I chose to be looking for FeSO4 the whole time, I already have the answer to B. If I go back over here, the answer to B is 3.12. B says number of moles of FeSO4 that will be produced, and the answer would be 3.12 moles of FeSO4 because we already calculated that. Now, if you had chosen to do all of these with some other product, you can, and that's great, but now you're going to have to do it one more time in order to figure out FeSO4. Not a big deal, but just I'm helping you to skip a step if you don't, because you don't need to do that step. Okay, so now we're at letter C. So it says how much excess is there of either reactant that was in excess? So the two reactants that were in excess, I'm going to start erasing a few things because
Wait, KJ, how the number of moles of S or FeSO4 that will be produced? How do you know which equation it is?
Because you're looking for the one that produces the smallest amount that limited the reaction. The reason that the third equation, so this one I'm going to pick another color here. The reason I'm looking at this equation here, oh crap, sorry, Will. The reason I'm looking at this equation here is that it produced the smallest amount compared to these two. These two produced more.
Yeah.
So that's telling me that this is the one that ran out. This one ran out. So it limited the reaction. It limited the reaction. And so that's the one that I'm going to be using. These two were in excess. There was too much of them, so there's a little bit of them left over. Once the water ran out, the reaction stopped, and there's a little bit of the first two reactants left over. Did I explain it?
Let's say the problem B was for moles, and I mean grams.
Yes.
And if we already have the moles from problem A, would we use the rounded version that we got as our official answer, or would we use the 3.116 repeated?
That is such a good question. Technically, we would use the 3.116 repeating. That would be the best way to go. But you don't need to, I don't think it'll affect your results on the test, but technically you would use the full number before you would round. So once you get all the way to the end. And it could be grams. I could ask you for grams. So if I did ask you for grams, everybody, let's see if you feel comfortable with that. I'm not going to go through the whole thing, but just I gave you moles. So now you would do 3.12 moles of FeSO4. And then you would do one conversion to get yourself into grams. You want grams of FeSO4. So grams of Fe, sorry about my crappy handwriting. Grams of FeSO4 is what you're going to need on the top. So you would put 1 mole of FeSO4 on the bottom, and then you would put the atomic mass of FeSO4, which I gave you here. I think I did. No, I didn't. Well, whatever. You would put the atomic mass of FeSO4, which could be, iron is pretty heavy. I don't know. Let's say it's 122. I made that number up. That's not real. But let's just say that's the atomic mass. And then that would give you the grams of FeSO4 at the end. Good question, Kate. Good question, Will. Will, do you feel like you understood how I picked the last one? And I picked it because it's the smallest of the products. We had 3 products, and the smallest one was the 3.12. So that's the one I know is the limiting reaction.
Well, so the answer of the number of moles of FeSO4 that will be produced is 3.12 moles.
Correct. So that answer, so answer A, to answer A, what's the limiting reactant? You would say the water. The water ran out first. And then the answer to B would be our answer to that one, 3.12 moles of FeSO4. Make sense? Okay, I'm going to go ahead and move on. So we're on C. How much excess would we have of the other 2 reactants? Just so you know, I purposely chose my reactants to be pretty close. So if you get enormous answers, then you probably didn't do it right. I chose them to be close so that you couldn't eyeball it and just know the right answers. So that's why. So you should be dealing with small numbers, and you'll understand in just a second. Okay, so I'm going to move down. I'm going to scroll down on my paper so that we can see. I'm going to write one note here. KJ made up. Because we're recording this, and I just want to make sure everybody knows that's not the right number. There's not really 122 grams of FeSO4. Okay, so I'm going to scroll back up. And we're going to look at part, I'm going to change colors again. We're going to look at part C right now. We're looking for the excess reactants. And it says you can pick either one, so I don't care which one you pick, but let's go ahead and work with, make sure I have the right one here. Let's go ahead and work with this one. I don't know if that was a good one to pick or not, but the K4FeCN6. So I'm going to write down, whoops, how much did we have of that? We had 3.23 moles of that. Oh, maybe that one was too easy. 3.23 moles of K4FeCN6. And the question is, how much is going to be left over at the end. So in order to calculate that, there's a couple different ways that you could calculate that. I'm trying to think of the easiest way. This one is a super easy one because it's just a 1 mole ratio. Trying to think if there's a different way to do this one. Give me just a second. So you have the 3.12. It's going to be, so let me jump ahead for just a second. It's going to be 3.23 moles minus, oops, that's a divided by sign. There we go. Minus the 3.12 moles that actually get used. So how did you know that it was going to be 3.12 moles that get used? So we're going to have to do a mole to mole ratio in order to see that. So give me just a second. We're going to put moles of K4FeCN6 on the bottom. And that was a 1 for that one. I got to make sure I feel like I'm doing something wrong, you guys. Give me just a second. What am I doing wrong? We've got the 3.12. I know how to do it. The 19.4, we would produce that many. So how many moles of it are we actually? Oh, we're using, that's what it was. So to the 6 moles of H2O. Give me a second. So 6 moles of H2O. I'll explain this in a second. I'm sorry, my brain is farting out. Just a moment, and it will make sense. So 3.23 times, whoops, 3.23 times 6 is 19.38. There we go. 19.38. And that's, darn but I'm not doing it right, you guys. What did I screw up? 19.38 is the moles of H2SO4. What was I supposed to do? Oh my gosh, I'm having problems in front of you all. Give me a second. What am I screwing up? Somebody tell me what I'm screwing up. I know how to do these. I've done them a million times. Give me a second. So you have 3.23 moles. You use the limiting reactant, and it had a 6 on it, didn't it? (18.7 moles of H2O. That's what it is. I did it backwards. Okay, let me start one more time, you guys. I'm sorry about that. Let me start over one more time. Hopefully you weren't writing what I was doing. Give me a second. So we're going to start, now I've got to figure it out. We're going to start with the limiting reactant itself. So we said 18.7 moles. Whoops. We said 18.7 moles was the limiting reactant. So 18.7 moles of H2O, that was the limiting reactant. Now, we're going to do a mole to mole ratio with the potassium iron cyanide thing. So I know I'm going to put moles of water on the bottom. I will do this a second time so you won't be confused. So let me do it again. I'm sorry that I was a little slow on that. I'm going to put moles of water on the bottom, and that's how I know that they're going to cross out. And what I want is moles of the, oops, that's K, moles of K4FeCN6. Why did I choose such a hard equation to remember? Oh my goodness. Okay, and that will leave me with moles of K4FeCN6 that I need. This is how much is going to get used up if the equation stops because there's only 18.7 moles of H2O. So let's do the mole to mole ratio. In this case, and let me just double check because I think it's 6 to 6 if I'm not mistaken. Nope, it's a 6-to-1 ratio. So water is a 6 and the K4 is a 1. So I'm going to make water a 6 and the K4 a 1. Did everybody follow that? And now I'm going to multiply it across. So 18.7 times 1, equals divided by 6 equals, there we go, 3.116667, whatever, 3.12. All right. So this is how many moles of, I'm just going to call it the K4. This is how many moles of the K4 that we got to use. But I gave you I'm going to double check. I gave you 3.23 moles of it in your original reaction. So 3.23 moles is how much you had, but 3.12 moles is how much you needed. So I'm going to subtract them. 3.23 minus 3.12, and your excess is 0.11 moles of excess of the K4. Okay, I'll do another one because I really biffed that one up. So my apologies.
Wait, KJ, why did we have to do that whole thing just to subtract the two?
That was a coincidence. Give me just a second to make sure that that was a coincidence. That was the only reason you had to do, the reason it was a coincidence like that, I think, is because it had a numerator of 1. Just because it had a coefficient of 1, that's why it worked out that way. Let me do one more and just make sure. So let's do one more, Will, just to make sure, okay?
Okay.
So let's try the other reactant. So I told you could pick either one. So this could have been your first answer. You could have said, okay, KJ, 0.11 moles of excess K4, and you would have been done. But let's say you did the other reactant. So the other reactant that was in excess was 19.4 moles of H2SO4. Yeah, this is why, Will. This one will show you really clearly why you couldn't just have subtracted. Okay, so what we're going to do again is we're going to start with the water. So we're going to start with the 18.7 moles of water. And we're going to put moles of water on the bottom. And what we're looking for is how many moles of H2SO4 we needed. So that's why moles of H2SO4 is going to go on the top. H2SO4 needed. Okay, how many moles do we actually need? So if we used this small amount of water, how much of the H2SO4 would actually get used up? Now this happens to be a 6-to-6 ratio. If we go back, 6 H2SO4, 6 H2O. So it's a 6-to-6 ratio. So 18.7 times 6 divided by 6 equals 18.7. So that's how many moles of H2SO4. Now the 6/6 is again a coincidence. This could have been a 3/5 ratio, for example. It wasn't, but it could have been. So you can't just skip a step. So I'm going to erase those for a moment. Oops. 18.7. Okay, so 18.7 moles of H2SO4 were needed. How many moles of H2SO4 were we given in the actual problem? Well, in the actual problem, we were given 19.4 moles. So now is when I get to subtract, not until after I've done the stoichiometry. The first one was just a coincidence. So 19.4 moles is what I started with. Because the reaction was limited by the water, I only got to use up 18.7 moles of the H2SO4. So I ended up with 19.4 minus 18.7, and I ended up with 0.7. Hey, here's a sig figs question for you. It's exactly 0.7. Does anybody know how to make it 3 sig figs? Add 2 more zeros to it. So 0.7, and that I don't care. I won't worry. You don't have to worry about that. But 0.700 moles of H2SO4 are excess. Okay, I'm sorry that took me a few minutes to work out. Okay, let's move on to part D. This is in part D, we're going to take a look at the percent yield, and I start over. And the reason I start over for the percent yield is in case you made mistakes earlier on, it won't affect your answer for part D. You're kind of starting from scratch. So it says the percent yield, if the theoretical yield was 5.7 moles of FeSO4, but the actual yield was 813 grams. So right away, what's sticking out in my brain is we've got a moles to grams problem. So I'm going to need to convert those moles of FeSO4 into grams of FeSO4 so that then we can figure out what that theoretical yield was in grams, not in moles. So I'm going to write down 5.67 moles of FeSO4, and I'm going to convert that into grams. So I know that I want it to be in grams. So that means grams of FeSO4 has to be on the top. And I know that I want moles of FeSO4 on the bottom. And one more time, this is a common mistake. When you have grams and moles, what does the number of moles always have to be? Always, always, always. The number of moles, one. Thank you, Sonia. The number of moles is always one. When it's grams and moles together, the number of moles is always one. It's how many grams there are in 1 mole. So we have to add up the FeSO4. I didn't add that for us already, did I? No, I added ones we didn't need. All right, so Fe iron is 55.847. And S is 32.064. And then oxygen times 4. I got 151.907. I don't know if anybody can double check my work and make sure that I did that right. It's hard to do it in front of everybody super fast. Okay, so that's the mass. So I'm going to do 5.67 times the mass, 151.907, to calculate my moles. Did I do it all right? Yeah, that's a lot of, oh yeah, no, I did it exactly right. So 861, my number's huge, 861.31269, whatever. I'm going to say 861 grams. This is our theoretical. So this is how much we should have produced. Now we go back to the problem. How much did we actually produce? Only 813. Usually your percent yield is going to be below 100%, but not always. If the reaction didn't go to completion, you might have above the amount that you're supposed to have. So it is possible to have higher theoretical, higher actual yield than theoretical. Okay, so in this case, it was 811 was the actual, and the theoretical was 861. Make sure that the units are the same. So grams and grams or moles and moles, but not both. So that was our theoretical, and then we just multiply it by 100. So I do 811 divided by 861. Oops, did that wrong. 811 divided by 861. And I get times 100 is, I'm not sure what that meant, Miles, but okay. 0.942. So 94.2%. 94.2% percent yield, and that should be it. Anybody have questions about that one? Okay, this is going longer than I expected, peeps. I'm sorry. Let's go back to number 3, the one I skipped, and then we are all done. If you guys need to go, be my guest. You can always watch the recording. You can skip ahead to the recording and watch the ending. Let's do number 3. So this was from the original equation. It said, I'm going to do a little erasing because we got a lot of chaos going on here. From the original equation, it says that we had 98.4 grams of Cl2. So I'm going to go ahead and write that out. So this is problem 3, and I'm going to switch colors. Let's try blue. Problem 3. And one more time, I already forgot it. It is 98.4 grams of Cl2. 98.4 grams Cl2. Notice I hardly even read the question. I wrote down what they gave me. Okay, so then next, whoops, wrong way. Next, I am looking for grams of MnCl2. So I'm going to put that all the way on the other side. Grams of MnCl2. That's what I'm looking for. Now, if you haven't written this down, when you're going from grams to grams, it's 3 conversion factors. Write it down. Grams to grams equals 3 conversion factors. So I'm going to draw 3 lines. 1, 2, 3. And just to get my pen or pencil moving, I'm going to put a few things down to help me make sure that I'm on track. Number 1, I know that grams of Cl2 has to go on the bottom, so those units will cancel out. So I know I've got that one right. I also know that I have to end with grams of MnCl2 so that I have that one right. So I've got a little bit of a starting. Now, any time that I see that I have grams here and I have grams here, you know it, I have to put 1 mole on the other side, whether it's the top or the bottom, it doesn't matter. But I'm going to write 1 mole of, oops, I started right grams, 1 mole of Cl2 on the top. By the way, it has to be Cl2. This can't change. These both have to be Cl2. We're going from grams to moles. Those are changing. And when you do moles to moles, you're allowed to make the molecules change. But when it's gram to moles, it has to be the same molecules. So 1 mole of Cl2 has, let's see how many grams. Cl2, 35.453 times 2 is 70.906. Okay, and then we're in moles of Cl2 right now. So I'm going to put moles of Cl2 on the bottom, and I'm going to put moles of what I'm trying to get into. I'm trying to get into MnCl2 on the top. So that's a mole to mole ratio. So the reason that this can be different from this is that the moles, the unit moles has stayed the same. So now I'm allowed to change the molecules. And this is a mole to mole ratio. So this is where I go back to my equation and I look at moles to moles. So I'm looking at moles of this one, MnCl2, compared to just Cl2 itself. So it's a 2 to 5 ratio, and let's go back and fix that. So 2 was for moles of MnCl2, and 5 was for moles of Cl2. All right, I've got my first 2 conversion factors are done. Now I just need to wrap up. I see that I have grams here, so I know I must put 1 mole of MnCl2. Notice that this is the same as this one. And I also see, let's do a little crossing off. I see that I had moles of Cl2, they crossed off. And I see I have moles of MnCl2, and they crossed off. So now all I have left is grams of MnCl2. So if I put that in here like this, we have to add Mn, which is 54.938, plus 2 chlorines, 2 times 35.453, close parentheses, is 125.844. So if you can correct me if anybody thinks I did the math wrong. 844. And now I'm going to multiply it all the way across. Lots of numbers here. So 98.4 times 1, I'm not going to type that in, times 2 times 125.844 divided by, and then in parentheses, I'm going to do 70.906 times 5, close parentheses, and I'm going to hit equal, and I get 69.8 here. This is what my answer looks like, 69.856145. What do I write down for an answer? Well, the 5 rounds this number up. I want 3 sig figs because I had 3 over here. So my final answer is going to be 69.9. And we can double check if I did that right, because down at the bottom I did put an answer key, and we hope I did it right. Yep, there's the answer right there. So it looks like I did that one right. Okay, that's it, everybody. Does anybody have any last minute questions? feel free to turn on your microphone if you have anything left. And again, I did record this whole thing, so you can come back and review the entire process or any one process that you need. How are we doing?
Will we be able to see our first round of testing?
You will not. No. That is entirely coronavirus. It just makes it difficult for you to release answers and everything like that. You have your work. You know, I can't tell you what part of your work you did wrong, but you have your original work, so you can look back at it and see if you can see what you may have done wrong. But
Thank you, KJ.
you're so welcome, Will. So tomorrow at 1 p.m., I'll post the test right underneath the photo at the top of our Moodle page. So it'll say stoichiometry retake at 1 p.m. tomorrow.
Perfect. Thank you.
Okay, bye, hon. And just FYI, you guys, we're going to have a little socializer on Wednesday. If anybody wants to play a video game, we'll make a group video game. So it'll be Wednesday at 2 p.m. If you can't make it, it's no big deal. But just, I wanted to give you guys something fun to do while you're studying for the AP exam and all that. Okay, I'm going to stop the recording. Unfortunately, this took longer than I had expected. So I'm going to say goodbye to the people that I'm recording. Goodbye, recording people.